In chemistry, whenever you take measurements or do any of the conversions, you need to be aware of which measurement has which base unit. So when you measure anything in a length in chemistry, we're going to be measuring that in some sort of meter, and that will be abbreviated with a lowercase m. Mass or weight will be measured in grams, and that will be a lowercase g. And be aware that mass and weight are not the same thing. In physics, we'll clarify what the difference is, but sometimes in a chemistry problem, they're used interchangeably. And then the last item we're going to deal with is volume. And when you take the volume of a liquid, we will measure that in liters, and that will be abbreviated with a capital L. We're going to be using prefixes this year. The prefixes are going to be added in front of the base unit when the quantity that you've measured is either larger or smaller than the base unit. There are 4 common prefixes that we're going to use during chemistry all of this year in the introduction. Now, there are a lot more prefixes. You can look those up in your textbook or online. I'm only going to give this little tutorial on the 4 common prefixes that we use. So, deci is abbreviated with a lowercase d, and it is smaller than the base unit. In fact, it is 1/10 the size of the base unit. And in decimal form, that would be a 0.1. Centi is even smaller. It's abbreviated with a c, a lowercase c. And it is actually 1/100th of the size of the base unit, or a 0.01 in decimal form. Milli is even tinier, and it is abbreviated with a lowercase m. And it is 1/1000th the size of the base unit, abbreviated in decimal form 0.001. Kilo is the big unit that we're going to be using in chemistry. It is abbreviated with a lowercase k. And how much bigger is it? It is 1,000 times as large as the base unit. In chemistry, you're going to be needing to be able to convert from one of your base measurements to smaller units or larger units. In other words, rather than meters, you may need to use centimeters and then change it to decimeters or kilometers. And the easy way to do this is just use a number line, because that's going to help you tell how far to move the decimal and the direction. So as an example, this red and black number line I've shown here, in about the center, that's where your base unit's going to go. And for today's example, I'm going to use a meter. A little bit smaller than a meter, 1/10 of it. Our prefix is deci, because it's 1 decimal place away. And if I had something that small, it would be a decimeter. So if this is 1 meter long, this is 0.1 meters long. So rather than the base unit or a deci, let's say we had something even smaller. Then it would be 2 decimal places away, and we would use the prefix c for centi. So that would be something that would be 1/100th the size of the meter, and I would abbreviate it a centimeter. If I were using that in decimal form, it would be 0.01. Notice I have moved the decimal over 1 more. So centi is 2 away from the base unit to the right, and so I have 2 places to the right before I have the number. Now, even smaller than that, remember, is milli. She's 3 away from the base unit. Lowercase m is the abbreviation for milli. If I had a millimeter, I would say milli meter. So I'd use 2 lowercase m's. The first m is the prefix for milli. The second m is the base unit, meters. If I wrote that as a decimal, it would be 0.001. And the other unit we're going to concentrate, prefix-wise, in chemistry, is going to be the unit that is larger than the base unit. And it is 3 units larger, and it is the kilo. And I abbreviate that with a lowercase k. If I had 1,000 meters, I could either say I have 1,000 meters, or I could say I had a kilometer. On this problem, you're going to convert 0.250 liters to milliliters. And I do want to point out something before we go any further, is that any time that we have a number that is smaller than 1, be sure you have a 0 preceding the decimal. That's what is called the dead baby 0. If you don't put that 0 there, think of it as a pharmacist who is trying to tell the difference between 0.250 and 250. If that pharmacist doesn't see that decimal and accidentally gives the baby 250 milligrams of a medication instead of 0.25, that baby is going to be dead. So it is a dead baby 0. We put zeros in front of decimals if the number is smaller than 1. It's kind of a gross way to try to remember that, but that is what we're going to do. So we're going to clean all of this back up. There. Okay. Now we're going to come back and work on this, but I wanted to point that out because I was doing it. I was putting zeros in front of the decimals if there was nothing there. But I want you to understand that you are expected to do that. Now let's get back to this problem. Okay, step 1, determine your base unit. Here I have liters and liters. Okay, number line, base unit is liters. 1 to the right is deci, 1 more is centi, 1 more is milli. Getting smaller and smaller and smaller going to the right. Going to the left of that base unit, 3 over, they're getting larger, and the one we're going to be concerned about is the kilo. That is setting up my baseline on my numbers. Now, I'm moving from liters to milliliters, so I'm moving from the base unit to milli. Question is which way? Well, I'm going to start with liters because that's what had the number typed with it. So I'm going to start with liters, moving it to milli. When I moved my little loops, I noticed I'm moving to the right. How many places? 3. So I will take 0.250. I'm going to move the decimal 3 to the right, which means my decimal is now here. I'm going to X out where I started so I don't end up carrying that wrong decimal with me. And so my final answer has a 0.250. Well, because the decimal's at the end, we get rid of the 0 that was out front to start with. We just don't leave zeros hanging in front of numbers. So my answer is 250. We changed it to milliliters. And to kind of make that more clear, if we had written it like that, that just looks weird. That's how you know if you started to write it as 0.250, just come back and take that 0 off that preceded it. Okay, our last sample problem is going to be how many kilometers are in 38 centimeters. So step one is our base unit's going to go in the center, but what is our base unit? Well, the part that is the same in both of these is meters. So my base unit is going to be meters. And I'm going to set up my base number line here. So that was my base unit. 1 decimal place away is deci, which is a D. 2 places away is centi, which is a C. 3 places smaller is M for milli. Larger is to the left. 3 to the left is kilo. So I have it set up. I've identified meters as my base unit. So I am trying to move in my problem. I want kilo and centi. So this one I actually have 2 prefixes already, but in both cases the meters was the base unit. So I'm trying to move between kilo and centi, and this is quite a few spaces. Where do I start? Oh yes, I'm going to start with the fact that the typed problem is centi. So I'm starting with centi, and I'm going to move to the other one. 1, 2, 3, 4, 5 spaces. In which direction was I moving this time? To the left. So I'm moving the decimal 5 to the left. So I'm going to write down 38, which is what we started with, and I need to move the decimal 5 to the left. Oh, this is one of those with no decimal. Oh yes, that means the decimal starts at the end of the problem, to the right of the number. I'm moving it 5 to the left. 1, 2, 3, 4, 5 to the left. There's my new decimal. X out the one that I started with. And I have empty loops, so I'm going to fill those in with zeros. That one's empty, this one's empty, and that one's empty. So that looks like my answer, except I need to be sure to add that dead baby 0, because this number is smaller than 1. So my answer is 0. 3 more zeros, and then I had the 3 and the 8, and what prefix did they end up with? We ended up at kilo, so it's kilo what? Kilometers, kilometers. And I'm going to put a square around my final answer. So this one was a little different. I ended up using the zeros in the empty loops plus the dead baby 0 out front. You know what? I think you can do any of your homework problems.